NTU World of Wisdom. Welcome to High Impact Thesis. In this podcast, we speak with researchers from various scientific fields to talk about the motivation, goal, and potential impact of their research. We also want to give you a sense of how a Ph.D. is carried out with an emphasis on the PH, the philosophical aspects involved in pursuing a Ph.D.
Okay, so welcome, David, to High Impact Thesis. We're glad you can join us today. So first off, we'd like, as always, to start with the general field that you're working on. So basically familiarize the layman of like your work and the motivation behind your work. Why did you get into it? And just basically an overview of your
All right.
area.
All right. Yeah. I think most of it started like 2018 when going through some AI books. Yeah, and it was quite interesting to see how it can impact the different safety critical areas, especially like law, healthcare, defense, autonomous driving, and so on. So this was kind of cool. I was still in consulting, so not quite a deep level going on there, but like good for management. And then I transitioned into the PhD. I arrived with most of the coding skills forgotten, and not a big idea on what I am supposed to do, particularly more like just like something with AI, something that's cool.
Right.
Yeah. So luckily I had a very initiative professor as supervisor who told me start with this, try to catch a deadline in 2.5 months, and then make your first publication. I'm like, sure. Sure. Yeah, so that went very badly.
And that was during your first few months in the PhD?
Yeah. I just arrived. It was like the first conversation. Yeah. Good start. Yeah.
Right.
Like failed miserably. Moved on, tried a few more times, and like got the first paper through, like I think 9 months, 10 months in, and it was about the testing of AI and integrating a secret sauce, which is called out of distribution awareness. So you can think about it like you're driving in an autonomous. Like you're driving an autonomous car. The sun is shining, beautiful environment, everything goes well. So you arrive home safely and everything was good. The problem is if there's suddenly a thunderstorm, then things can get tricky. Like the scenario is rarely encountered by autonomous driving systems. When suddenly like all the sensors and cameras see new stuff, they may behave differently and run into a wall, which is bad and you want to avoid. Yeah. So this is a scenario that's quite common in most spheres, like autonomous driving, healthcare, and so on. And AI testing did some stuff to create mutations which can cover most of these situations, but you're not always sure how realistic they are. So you want to filter the bad ones out and keep the good ones, the challenging ones inside. Yeah. So with the out of distribution was the idea to understand the neural behavior, to identify those which are relevant and those which are not. Filter out the ones which are not and try to retrain the model with the good ones so that when the next thunderstorm comes, the car performs well. Yeah. So that's the basic research idea. And this was going on afterwards through the application review. So try to integrate this out of distribution awareness testing in the cybersecurity domain. Try to integrate it in making systems more fair by understanding the data distribution for both genders and then trying to fix them to overlap. And through this, 6 works came out of it. And now Now the idea is to make some impact with that,
Mm-hmm.
to use the
Right.
ability of measuring the quality of an AI system in order to standardize it, so that car manufacturers or those who do the AI for the car have certain quality thresholds they have to align with before they can put it on the street. And the same goes for healthcare, where you want to make sure that, like cancer or diabetes diagnosis is done at responsible levels of quality, and the doctors don't rely on systems clients or patients shouldn't trust it. No. And so therefore me and my professor now co-lead the national standardization of AI here in Singapore, and joined with 20 other companies, ministries, and universities to bring this to life and create the world first quantifiable quality measure based standard for these safety critical areas. And now expand this to Europe through the German Commission and to North America through the Canadian one. So that's the current.
It seems your work has quite an impact.
So far, yeah.
Already
going
all over. Interesting. So, if you don't mind going a little bit more into details, like when you say standardizing these AI models, what kind of parameters, what kind of metrics are we looking at?
So I think every model is a little different for every task. So if you go on a hyperparameter level for every model, things can get quite messy. And then you look at the current regulations, like which are done by the European Commission. There you have quality measures such as you need to be fair, you need to be secure, you need to be cyber secure, maybe safe as well. And then you ask them, so how? Well, figure that out. So that's a little tricky. And in order to make this a little less tricky, we try to go one level deeper to say like, okay, you have expectations to how explainable a system should be. Good. So depending on your level of risk, you try to expose your application to, there are different levels of explainability you have to provide. When you have a simple recommender system for your Netflix show, all right, show that you did everything well during the development, report it nicely, because like you have some behavior manipulation or maybe behavior modification that you can do here, and then it's okay. But if you now go to healthcare, for example, the doctor needs to understand why this is a particular type of wound, what areas of the image were especially influential to making such prediction. So now you can visualize that. And maybe then for a third level, like for military grade applications, where generals need to make quite substantial decisions. You need to aggregate all the input information the AI receives to understand what information the AI was presented by, and then aggregate it in a way that's humanly understandable, and then integrate the output of the AI in addition, so that both can be combined to make a conclusive decision. So there are like different levels you need to adhere, and thereby you can say, all right, how you eventually do that, with what hyperparameter settings, show that it works, show that you have a certain level of quality achieved, and thereby it should be fine. Yeah. So that's now the one level approach we try to pursue, so that there's a little more operationalizability of the regulatory environment.
So in your day-to-day, then you're working with researchers or regulators, or you're more an interface between these two groups of people. We'd like to understand on a day-to-day, are you building models? Are you assessing models? Are you what's it like?
No, understand. Like not so much research anymore right now. I would love to do more. The main focus right now is to read most of the ongoing approaches of other countries, of other committees, and manage the group so that the outputs are meaningful to the general sphere, and integrate the capabilities of the research we are surrounded by here at the university so that it can help to create such standards. Yeah.
Right. And did you find yourself building on existing standards or
Yeah, of course.
from scratch?
So the group we structure into three pillars. One is the foundations, which looks at the ongoing regulations out there. Like ISO, the International Standards Organization, is the foundation most people contribute to. And then we have the team Right Fit, which tries to use the use cases in Singapore, the ones most crucial to the national AI strategy, to have the right vehicles to explore how the regulations may apply. And then the final one is the capability team, which provides the techniques and tools to measure and quantify the systems.
And so from an operational point of view, when I have
Yeah.
built a model,
Yeah.
at what point do you come in, or when do I come and, well, how do I interact with you? Like, how do you know these guys or this team build the model according to standards?
Yeah.
Their protocols already.
You being
written.
Christopher, or you being
so me being say my
company?
company, or but I have a model that's going to be used in the public, right?
Yeah.
And we
Understood.
want to know, or you or some government entity wants to know if it aligns with the standards. Like, what is the process? Because right now I can build a model and just push it on the web, right? So you can use it.
Yeah, but like also this is, I think, big misconception in research I also stepped into, because I also thought, all right, I have my data, I have my model, now let's go. Let's put it out there. Let's have some fun. Problem is, there's like a whole ML ops pipeline from data collection, data management, model management, and then versioning, how the inputs are received, how you monitor it, how you make sure that there's no shift, so that all classes are maintained. And so there's quite more going on around it, which needs to be measured. So you encounter the regulation sphere, I think, first, if it's safety critical, like human centric application, I think then the scope is relevant. And then when you want to deploy it, that's the point where you can think, all right, does it make sense to get a nice stamp on my website which says certified by Singapore AI standard, and thereby may help in user adoption or governmental trust? Or is it for showing that you're better than a competitor when you try to pitch your solution against another one to a government which tries to buy that for some service? So using these quality measures, you can compare yourself from a whole new perspective, far exceeding the current use of some test sets. More country specific to the environments and conditions you may then encounter.
So instead of me telling people that my model is 88% accurate or something like that, what I would actually bring to someone who wants to use the model is that I have been certified by this organization or entity, and then that would act as a proxy for saying it was checked properly, it was done properly. That's the approach that you are taking.
Correct. It's like when you go in the elevator and you see the trust stamp, so you feel safe and you don't think the elevator will go down.
So it means we're gonna have different
on the window of autonomous car. That would be nice, and like people would say, "Yeah, I'll take that one home."
Okay, so there's gonna be different brands of models. The same model for doing the same task, but one one built to higher standards, and another built to different standards. Then they would be seen differently in the world. I guess that's the idea. Okay.
Right. So you mentioned like you're not really much involved in research right now. So what is it that you are kind of working on a day-to-day basis?
Yeah. So to operationalize the research into a meaningful context that's beneficial for adoption. I think the validation of that is quite important to make sure that whatever we come up with, whatever quality measures we define, that's helpful. So we need to find the right people or ministries or companies to provide the representable use cases in order to test if it's helpful or not. And the main majority of work now is to get a conclusive picture on what capabilities are available, both here NTU research and out there provided by others, open source. For example, Microsoft had a recent release for, it's called Counterfeit, and they try to penetrate an AI system with adversarial attacks to test its security against human attacks. So like, these are all tools that can be utilized, not mandatory set because that limits innovation and adoption, but at least utilized to demonstrate some certain level of quality. And then this needs to be combined with the different adopters who provide the use cases. And that's quite a bunch of work to put that together and then to make sure that it's useful, then document it and aggregate it into a nice outcome, which can be shared, feedback gained, based on which then the first draft of the policy can be written, which we now target for September. Yeah.
And you mentioned like working on different applications, right? From autonomous vehicles to health to security. Is the conversation with different sectors like, are they completely different from each other? Like the type of kind of like
if
so basically
if you can't provide a general approach, you mean?
Right. I mean, you just mentioned a series of steps going from the research all the way to the implementation and the standardization. So is that type of process differ from the sector to sector, or there's like a general guideline to follow?
No, I think there are guiding principles we have, like those, for example, mentioned by European Commission. You have the security, you have the explainability, you have privacy, but all of them are necessary in all contexts. So for example, or fairness, right? So for banking, fairness is very important. You want to make sure that a man gets the same credit ranking as women which have the same standards or the same features unrelated to any type of gender, ethnicity, or whatever. So there, this component of fairness is very important. And when you look at autonomous driving, not quite. Like if a man or a woman sits in your car, it doesn't matter much. Or like if a man or a woman walks in front of you at the street, you just want to make sure that you don't run them over. Yeah, like this has nothing to do with fairness. It's just security. Yeah. And then so I think that's one. But there's also some hidden things, like it's for healthcare, for example. You have a diabetes wound diagnosis system, and now a woman, or like the data is collected mostly in hospitals from areas where certain kind of ethnicity lives, which may earn in this neighborhood a little more. So the data is trained with ethnicity specific data, and the system then may behave with this ethnicity very well. And then when someone from another ethnicity comes, the system underperforms. That's something you would like to avoid, because eventually, like, we should be treated equally, even from a performance aspect. Yeah. So therefore, even like those things you don't really see it at first matter on the application you try to pursue or solve. Yeah. So the way to analyze how these certain expectations for security, explainability, fairness, etc., apply varies among the system. It varies among the domain itself, especially where the nature of the data is also so similar, so different. In healthcare, you have the computer vision. In banking, you have mostly the label data, or like the tabular data. Yeah, that provides different requirements and different models with different aspects you need to take into consideration when doing tests. Yeah.
Okay, so I kind of want to expand on that a little bit, because that's been a common problem since the beginning, right? The system would be as biased as data collected. And you just mentioned we are targeting for fairness and everyone should be treated equally. But from a standardization point of view, you're now setting kind of set of guidelines on how to collect data and kind of make sure that the results in the future be fair and equal. So how do you go about that? I mean, it's been a difficult problem for a long time.
I mean, there are existing solutions that provide, first of all, the understanding of what metrics should be used for given application. And then there are the libraries or tools to show that you adhere to such levels. And while not perfect, using the use case studies out there, the Monetary Authority of Singapore, for example, did a very good use case study with HSBC in collaboration with Element AI under Joshua Bengio, where they conducted the credit scoring use case, and they provided a full guide on how to assess certain criteria of fairness, such that the validity of certain aspects relevant to the banking sector can be fulfilled. Yeah. But what systems do you usually engage with? What type of do you engage with AI in some sense?
Not at the moment, no. I think more Christopher than me, yes.
I mean, I do. So my work is more, you have these images of the ionosphere. The ionosphere is like a layer of plasma that surrounds the planet. And so we take these we can call them false color images, because we're using non-visible frequencies like HF, HF frequencies, and probe the ionosphere. Then, so we have some images on what we call them ionograms. So for my work, is just really predicting, is it anomalous or not anomalous? It's like you got a bunch of images of one class, and you're trying to find something that's not from that class. Okay, it's
and the higher goal is to.
So the higher goal is to predict if there will be that anomalous situation in a day in the future, because when there is this anomaly in the ionosphere, this will affect your GPS. Okay, it will affect some systems that use certain frequencies, and so we want to predict the situation. So for my
what
model,
type of data are you dealing with?
It's primarily images.
What kind?
It's really it's a little hard to describe because they're not real images. They're like you have numbers and you map them to colors, right? So they're not like what you would see. It's just you can have an antenna, and with this antenna you can send a wave up to the sky, and then you get reflected at a certain height. Okay.
All right.
And then we have an image of that process where you have on the y-axis you have the height of reflection, on the x-axis you have the frequency that you use for probing. So what you have is a chart of just height versus frequency. So for me, it's not so much about say fair. Is it fair? Is it not? It's like it needs to really predict that it will. If it doesn't predict that there will be irregularity in the ionosphere, then people who use certain systems that are affected will not prepare for it, right? So ideally, you want it to be accurate for the reason that otherwise no one would die really. It's just that in some cases you'll have people who would have made corrections to the GPS calculations. They're not able to do it because you made a wrong prediction and so on. So I find
you're
it
helping
interesting.
GPS signals to work better.
That's one area. It's just the whole process is called scintillation. It's like you have, when there's this irregularity, there's something called scintillation, whereby the wave, it's like the sun blinking when there's a cloud that passes by, and want to predict those situations. And GPS uses a frequency that is affected, but there are other areas as well for people communicating on the ground that use the ionosphere as like a mirror. So you shoot up a certain wave and then it reflects back to the ground. And those guys are affected by these irregularities. So
got it.
Yeah, my specific case is just that. So it's good. It's it's one of the things that I think why I thought it'd be nice to have a conversation around standards and what it means for a model to be good is because when I began to do my research, I had this model that I was very young in the field, so to say, but I had a model that was just constantly, my data was skewed, right? So my data is skewed because the normal situations are far more common than the so-called anomalous situations, right?
Yeah.
So it means that you can create, and I did create a model that just always predicts that there is no problem, right?
Like
And
thunderstorm.
yeah, so but this model it's very dumb because it never predicts that things will be bad. But it's when I report it to someone, the accuracy is very high. You know what I mean? If I can tell the accuracy is like 97%, but it's not meaningful if there were 97 things that were the same of one class, right? It's not a useful metric, in other words, right? So I think it's definitely worth checking then what was the data like that you started with, what was the process of training, because just reporting metrics can be quite confusing and perhaps not.
Yeah, exactly. Like you need to get the full picture on how something is created in order to understand whether or not it fulfills its purpose.
Right.
Yeah, and you somehow need to trust that this documentation of how it is created is truthful and done correctly. So therefore having the ability to validate technically, that would be nice. Yeah.
Right. Yeah, I think at the end of the day, it all comes down to trust, right? Like, do I trust the results coming from the system?
Yeah.
And
I think that's really the beauty. Like if trust could be reached for the majority of people to enter into an autonomous car, like adoption would go up significantly. And like even though like Tesla can show, look, our cars make much less accidents than humans do, it's still the problem. Like it's still too many out of a regulator point of view, because whose fault is it in the end? You can't blame someone because he was drunk behind the steering wheel. Like, and then at the same time, should you blame the developer for making something wrong? But like that something is already better than any human before. And yeah, it's very difficult to find the right answer for that. And that makes it so hard for adoption to rise, I think. Yeah.
So I wonder to what level it's more tradition than the technical aspect. I mean, it's more a matter of regulation than it is a matter of a technical question, because the example you gave just a moment ago is that you have an autonomous vehicle that's better than humans, that you can point to numbers, you can show that it works better. And I assume there could probably be cases like that as well in the hospital where you have an algorithm that works better than doctors. It's able to predict whether it's malaria or whatever. It does it better than doctors. And for some reason, people might still say, no, I'm not going to trust this thing just because it's a machine. I don't understand it. I don't know why it works. And I'm wondering whether it's tradition and whether it is something you as an organization or as an entity trying to standardize have to fight against. In other words, yes, you can prove with the numbers that this is a better model, but then pushing past tradition or the way things ought to be done. Do you have to deal with that?
Yeah, I think it's a matter of time on one side. So for more adoption to grow and more people to try things out. Because I think Apollo, which is the autonomous driving system from Baidu, now has 3 million plus rides covered already. So people are willing to try it out, some of them, first bunch. And with this, I think you have this usual S-curve of adoption. I think the only risk there is that if something very ugly accident happens, then this adoption curve, I think, can have significant slowdowns, significant pushbacks, if there is not the framework for developers or for companies to fall back to, based on which they can show, hey guys, we tried our best, we followed these guidelines, we can observe the right level of quality, and now we hit a mistake. And I think the real challenge is to show conformity in throughout the development process. And then to show that also after you developed it and you deployed it, the monitoring is going to predict when the system gets a little shaky, when the system may change a little or is not applicable anymore to what it's supposed to do. And I think then it's good to have the flags which can show up and say, hey, I'm not sure about what I'm doing. Or let's say if something happens that you have the agnostics or the understanding, the insights, like the black box of an airplane that can tell you what went wrong, for you to give a reasoning justification of why it went wrong. I think that's the most important aspect, because as soon as you can show exactly why something went wrong, you can also improve. And once you improve, you can show I will be better in future, even though I'm already much, much better than for what humans are trained for at a specific task. So I think thereby trust and continuous improvement enable continuous adoption.
All right. And as far as I know, you're still working towards your PhD. Is that correct?
Yes.
So what would be the remaining of your study
the
from now on?
enhancement
Because
of the
now you're more
quantification
into...
ability.
Sorry?
The enhancement of the quantification ability. So right now, I still have around 2 years left, and it's quite nice to take some time to understand what's really required for adoption in safety critical areas to take off, and thereby to understand what aspects someone really has to show to be secure and reliable, and how the model behavior understanding can help in justifying why something bad happened, something bad will happen, or something bad will not happen because you're secure. So gaining these thought understanding of that now is extremely helpful in creating very impactful work once, like, let's say the first policy draft is through, so that the next research item can be focusing on how the existing techniques can enable these requirements, and to make a nice bridging work where the state of the art can be tailored specifically to this direction, and then add the validation aspects to this work on real world data sets to show some solid validation of this, which is very welcomed, I think, in many scientific communities, as long as you compare yourself to the baselines, of course. So I think having 1 or 2 more of these, that would be great, and I think then that would be a nice thesis to submit. Yeah.
So as a researcher on a day-to-day, wanted to hear about what tools you have used that can be applied not just in your AI research, but in general as a researcher. What are some tools you've found useful, whether it is specifically for your work or about life, but something that our audience who might be doing research, who will be doing research, might be interested in hearing, like some techniques and tips and tools.
So I think I first started to learn PyTorch, using mostly re-implementing existing approaches to get a feeling of how the algorithms they explain in the paper actually work in practice. Most of that was done in PyTorch, and it really seems like the scientific community moves more and more into PyTorch, and the industry moves more and more into TensorFlow.
That's what I hear. I'm wondering what is going on there.
I think PyTorch is quite straightforward to build, and I don't have too much experience with TensorFlow myself so far.
Okay.
But it seems it's much better scalable for large scale data solutions. But who knows?
Can you tell us a little bit more about these tools? I mean, I'm familiar with the general idea of TensorFlow and PyTorch, like in building AI systems. But maybe you can give us more details about how to actually use them in practice.
Yeah, of course. So like very early, if you program a neural network from scratch, it's quite it's quite an effort. Like you have tons of matrix multiplications, and you need to define your activations on how each neuron is activated, like what activation function you choose, what learning rate you choose. You need to integrate that into the learning, which is like the backpropagation phase, where you have a certain loss function that calculates how the neurons are activated, and putting that all into matrix structures and laying the functions over that. I think that's quite an effort. And especially if you want to collaborate with others, or like others have breakthroughs with their architecture. Now you need to import like crazy amounts of data structures. And how do you handle the inputs? How do you transform them to suffice certain requirements for best practices suggested for certain fields? And then things get quite complex. And I think with these frameworks, what they're really great at is to provide generalized data structures for input, generalized ways for outputs, and generalized ways to define your model architectures, store your model weights, so that these models can be shared and reused. Like there's like this GPT-3 or transformer models, BERT, consisting of millions, sometimes billions of parameters or neurons inside, and then you have suddenly the ability to share that with someone else who fine tunes it to his domain using his data, because he can put it into the generalized input, and then can use that for his application, which is then much better. So the way to engage is, I think, significantly enhanced, not to mention the way how that can be optimized from a computing perspective, how your GPU can be leveraged. There's like this whole NVIDIA-based environment, Conda, which gives you the ability to quickly use all of the GPU power so that models can be trained very quickly and can infer the result very fast as well. So I think for that, these tools are the very great practice for complex deep learning systems. Yeah. And like, it started with PyTorch, and then you have the NumPy for efficient data types.
Right.
And what else? Like you have the Conda, like the GPU based environment, and I think what was really fun was to dealing with many servers in parallel to meet a deadline, because like tons of experiments had to be done in short time. And then managing 3 servers with 32 gigabytes GPU equipped, and then putting one experiment there, next experiment there, next experiment there, and then like pushing more and more processes onto the different GPUs, and then parallelizing all of that. Yeah, that was amazing. Like, wow.
Right.
That was super fun. Yeah.
So for that, you use PyTorch, you said?
Yeah, mostly.
Okay, nice. Because I think one of the beauty of these, I think, frameworks is like you need to know some math, but not a whole lot. I think that's what I
Yeah, that's my saving.
using these frameworks. They really are like an interface to math itself. You know, it's like I can access. You don't even have to know what is parallel computing. I mean, you have to know a little bit, but like you do a few tricks and you're in. So it's really amazing.
Yeah. But I really enjoyed the foundational math, like during university, when we learned how the whole neurons and weights are defined mathematically, how the backpropagation takes place and then enables the network to learn, and then seeing how the derivatives work with that to enable the learning process. That was just like really cool to see. I highly recommend, like, at least once to implement like a multi-layer perceptron, like one of the early stage neural networks oneself. It's super cool. Because then you really like see how, and then like plotting the graph in real time of the learning rate, that's
Oh, that's
mesmerizing.
interesting.
Yeah. Super cool feeling.
Cool.
Okay,
Mhm.
we'd like also to talk a little bit about where all this is going, right? The future of your work and all the things you're involved in. So, for example, let's take the example that Christopher gave, right? Like
Yeah.
he's trying to train a network to recognize certain anomalies in the atmosphere, and he's getting a very high accuracy, and he can tell by himself that okay, this is not actually what I'm looking for. That this is not doing the
Mhm.
things that I want. Do you think in the future the system itself will be able to recognize this?
So that the system recognizes it does not meet a certain quality level.
Right.
Uh-huh.
Because we always set goals, right? We have some certain goals we want to achieve, and right now it's us who have to evaluate whether the goal was met or not. The AI is just doing its thing, right? Like doing the calculation and giving you the result. Do you think we might find a way to make them self-correct, self-adjust?
I think it depends how you validate if something is correct. So
Hmm.
looking at the training process, you have different ways to see that. You have self-learning principles where you don't really tell the AI what it should do. You don't supervise it, meaning you don't tell it after each prediction that was right and that was wrong.
Right.
Instead, it somehow tries to reason about the data itself and build its decision logic. And then, usually in the last iterations of your training, you fine tune it to say, all right, you have 5 different decision criteria. Now let's fine tune the final weight direction so that these criteria can be met or these classes can be predicted. And then, of course, you can use your test set and evaluate it. But yeah, I think it depends on the application. If you look at a very difficult one, for example, yeah, let's do autonomous driving because I think that's quite cool. Streets look different in every country. Sometimes even the direction at which it's driven is different.
Right. Different
UK
laws.
guys and Singapore guys try to like say we drive on the left hand side, and then others say no, we drive on the right hand side. And then like here we have palm trees. In Emirates we have deserts. In Europe we have like these beautiful houses everywhere which look different, and like the environments change.
Mm-hmm.
Yeah, even the signs look different. So how do you make sure that your autonomous driving system, which you trained in the US, performs equally well in Europe, or not even in Europe, like in Germany, no, or England, where you suddenly drive on the other side? So I think what would be really cool is to have a country-specific evaluation data sets or country-specific evaluation protocols which respect the country-specific features you have to make sure you adhere for. Or this can be also an analogy to certain sectors or applications in industry. Problem is like, how do you make sure data is not stolen and then just like optimize towards that data set? That's a big issue. So having a more, let's say, generalized approach in measuring quality through some synthetic testing and model behavioral understanding, that would be great. Because eventually you want to make sure of 2 things. Your input space has been tested under sufficient completeness. Can't be 100%, but if you can test almost all of the majority of scenarios, then you're good to go. So you need to understand what are the overall conditions, environments I will face when I am deploying my solution. And then how can I use synthetic synthetic test case generators, with whom I can generate the necessary diversity to test all of these areas. And then I need to look at the model behavior. How is the model responding to these different kinds of mutations? and through which inputs do I stimulate new neural activations. So I can trigger new neural behaviors, and thereby I can check how the network will behave under these different inputs. And you're having this, so looking from a model completeness point of view with an input completeness point of view, then I can truly say, all right, this has been tested rigorously. Let's find out what happens when we now deploy it. Yeah, I think this should be the direction in which it is going, joined by the mutation capacities in being more realistic, more semantically guided, so that the data insufficiencies, which are likely in industry, are avoided.
I see. Yeah, that's sounds very realistic. Yeah.
So in the, I think one I guess follow up on that is in the process of training itself, and you mentioned this just a moment, it's that right now the model is told you did right or didn't do right, and you I don't know, you have some metric that you're tracking, right?
Yeah.
Wondering whether in the future it would be possible for it to just know what is expected of it. But as in by
like it defines its classes by itself.
Yeah, it defines its objectives. It defines what it needs to do in the world. So I guess it's more like you have you tell it that it should park somewhere, and then it knows what metrics to track in order for it to park there. You don't really say track the loss, the difference between this and that, and so on.
Yeah, like reinforcement learning approach, where you define some goal or some reward, but how it does its task, you don't really care about. You just let it go into the right direction by giving it some reward. Yeah, I think also what's quite cool is like if you have like a little more further in the future, let's say you have, because eventually any type of system, organic or synthetic, needs some purpose. Yeah, like that's either defined mechanically or through some neural training over time, embraced through parents or environment.
Right.
Which then activates you to go into a certain direction. So I think what would be cool is like if you train a model without any defined classes, then it somehow tries to build a function towards all these kinds of features you expose it to. So for natural language, you have the embeddings which resemble all kinds of words or characters. And then these words and characters form different similarities between each other. Based on the similarities, can form similarities between sentences. And then these sentences suddenly then evolve to logical structures, which try to do something based on the purpose defined by the majority of humans. So I think that's quite interesting to see in what direction that then may go, as you somehow reflect the consensus of the group of humans you have exposed the system to. And if the purpose of such humans can be reflected through what they say, or write, or say yes or no to, and thereby then see what the output is, depending on how you define the output, whether it should be generative by generating text or actionable by generating arguments or certain decisions, and thereby trying to get an understanding of what the overall consensus of humanity is. I think that's quite interesting. Yeah, although scary maybe, because those usually who have something bad in mind talk more. Need to stay unbiased here.
Yeah.
So you, let me just I guess not really follow up, but like I'm wondering, as humans, we are not in the business of optimizing for a specific. I guess we might be optimizing for something.
Yeah.
But I mean, people have talked about generally intelligent machine as in something that's not just about classifying this and that.
AGI.
Right. but something
Yeah.
that perhaps learns what to optimize for. Because I think if we are optimizing for something, it's not like just avoiding cause, for example, right? We just don't want to avoid cause. We want to also avoid eating the wrong thing. You want to avoid like lots of things that we have to sort of, in a way, train to recognize and so on. So I'm wondering whether you see that aspect having
Yeah.
become more possible now, since this AGI thing has been around for many, many years. People have been talking about it, and now we
So
have
like,
many computing power and so on.
based on what do you make decisions? Isn't it like based on the endorphin, dopamine, etc., which is put out into your brain? So how would you define the endorphin and dopamine for the AI that you want to train?
I don't know if that's how that's what we do right now.
I mean, that's quite a reward, right? Like if you can get this win, if you have your paper accepted and the endorphin is like exploding in your brain, and it's like, wow, right, great stuff. At the same time, when you have a nice company or like you do some exercise and you feel the dopamine rushing through your body, it's like guiding you to do more of that. You get more money, you can get more, and you feel it, feel more happy. It's kind of motivating.
Right.
Yeah.
I remember an introduction to business class I took my undergraduate, and in the first lecture, the lecturer gave us this kind of guiding principle to the businesses, which is like people consume to be happy. Like that's it. That's all there is to consumerism. It's just people want to be happy, want to feel, and then this happiness, like you said, it comes from these chemicals in our brain and in our bodies.
Yeah.
I'm interested in understanding what is it that we would optimize for a general machine.
So what inputs would you give it?
What kind of rewards?
Yeah, what rewards
No,
would you give
what
it?
data would you expose it to? Like we try to get the reward by ourselves, right?
On the one hand, we as humans obviously are optimizing for something. Like we want to optimize something, but I'm wondering, what is it? Because I don't think this question is settled. I mean, yes, there is this element, new explanation, where you say we want to increase the amount of. We always want to do the things that increase or that produce a lot of dopamine, or it's a sign that we've done the right thing. But this is the
Or let's go
explanation.
down to the basics. Like we want to survive or reproduce.
It all comes back to survival.
We've
had a lot of conversations where that was kind of baseline.
Let's go down to survival first for oneself, and then as race. And for race survival, we have this great thing for reproduction. So that's good. So we have these two baseline motivations. So similarly,
how would you translate that with the machine? How would you translate these motivations that guide all living creatures?
So like if you have an AGI, like assuming you have an AGI and now you want to, like you need to figure out what gives it its juice. Where does it take its energy from? Yeah. And I think if you limit this energy source, then whatever it tries to do doesn't work as good as it should be because less energy available. So the source for the energy limitation should be identified. Like, what is causing me to now be less good? Someone tries to limit my energy consumption. Need to get rid of someone.
So this thing needs to be able to monitor its energy, metaphorically speaking,
it has some motivation, whatever data it consumed, whatever information it processed. And now someone tries to steal its energy.
This sounds very much like the prequel to the Matrix movie. It just decided to use all humans as an energy source eventually.
Right. Oh, right. You could even extrapolate it in the other direction, right? Like if you consume more energy, you also get better at your task, and thereby you just try to figure out how to get more. Wow. Yeah.
Yes.
Not bad. Yeah.
Well.
Yeah. Let's regulate it sufficiently.
True.
Yeah, but like I think what's quite good to see is like even if you have an AI system that has as much neurons as humans, the effectiveness of each of these technical ones is much worse because the way they are connected and the way they talk to each other is much less efficient than what our brain can do.
I see.
So the functions between the neurons are still very immature to adhere to do something that goes beyond a specific task. Like if you have certain levels of complexity, one is you train a system to do only one specific task. That's where we are, I think, right now. Next one is that you have a system where you can do maybe 2 or 3 tasks. That's where we are currently heading with all the pre-training that's done, like GPT-3 being trained on a bunch of words and data, and thereby can be fine-tuned at the second step towards a given application, solving not only one but many problems. But again, like you need the additional data for fine-tuning. And then I think the next stage is to have something that can do a little more than that. And for that, I think the effectiveness of the functions between the neurons is a little immature. Yeah. And I think also like I think we are already overwhelmed with the capabilities AI has at hand and the immaturity of how data is currently stored and used. So industry and government needs to catch up first in using the technological advances we already have right now in research before we can push any further, in my opinion. Because that's if one has crazy control with one very good system and all the others can't catch up, then that's a scenario that's not so preferable. So having this data readiness and the trust and adoption in place, I think widens our understanding of how we want to deal with these more intelligent systems of the future. Therefore, I think it's very good to stimulate adoption under a safeguarded and growth-oriented way.
Okay, David, we're going toward the end. And so right now, we'd like to find out a bit more about you, the person. What kind of personal interest do you have when you're not doing AI and talking about standardization? What person are you?
Oh, you mean when I go into the Matrix? Yeah. I love the movie, by the way. That's one of my favorites.
I think I haven't watched it, but maybe I should.
Really? You should. Super cool. And afterward, you will wear the leather robe and
Sunglasses.
the fancy sunglasses. I love wakeboarding. Like wakeboarding is super cool, especially in Singapore, where you can jump behind the boat and do some rounds. It's a lot of fun.
Running, sounds fun, yeah.
Yeah, it's super cool. And like you get 4 friends, 5 friends, and then have a good time. It's very nice. Yeah, running is very enjoyable too. A little humid though, sucks. Europe was more fun for running, that's for sure. Yeah, but plenty of nice areas to go to. That's for sure. Yeah,
very cool.
Yeah, I think so. And listening to some audiobooks, I enjoy that, especially in the morning. Widening some new perspectives.
Nice. Do you listen to podcasts about research, like the High Impact Thesis podcast?
Oh, I can highly recommend that to the audience. Like, you should listen to all of them. Also, great moderators. Yes.
Thank you.
Yeah.
All right. I guess I think that's about a good time to wrap things up. David, thank you very much for being with us. I mean, it was a very interesting. I mean, we never had such a conversation before. And,
cool.
So appreciate your time and.
Thank you for having me.
Very much.
Yeah, also my first time on such a platform to speak with you. So cool experience.
Nice.
Yeah, appreciate it. Maybe we can do this in person sometime in the future.
Yeah, definitely.
Cool.
So that would be it for today. And we hope you enjoyed it.
All right, guys. Thank you
Okay,
very
thank you
much.
very much.